Hello, everyone. Welcome back to our weekly Sunday meeting. So, this is our 95th consecutive DMA, IMA, NDB meet. And we are discussing about the CBC today. This is the topic that was in demand. And Dr. Nidhi very kindly has agreed to take up an entire series on CBC. We will be discussing the RBC parameters today along with a little, along with some things COVID, not all things COVID, but a few things that have the COVID update that we do usually. So we'll be starting off with that. And we are blessed to have Dr. Nidhi with us, who is the Secretary of IMA and NDB, and also the Associate Medical Director of ENT and the head of the Safety Committee in Shroff Charity Eye Hospital in Daryaganj. She has very graciously agreed to take these sessions on for us. And today, as I said, we will be discussing about CBC. So without much delay, I'd request Dr. Nidhi to please come forward and carry forward this session. Over to you, Dr. Nidhi.
Thank you so much, Dr. Meenakshi. In the last week, again, there has been so much polarization and controversy and fresh news. We all think that, it's all over. And then suddenly a new variant emerges. And there is some part of the world which deals with it. And we just can't get out of discussing it. But as Dr. Meenakshi said, probably from the look of it, in another month or so, we can just call it quits and say that, we'll discuss science, but we'll not discuss COVID after another 4 or 5 sessions. So I'm into that. And let's start today's talk. So we are going to talk about COVID, what has happened in the last week. What is the relevance of natural immunity? Do we need so many boosters? And we will begin our series on decoding CBC. Part 1 being RBC parameters. Now, when you dive deep into this, you realize that RBCs are more than just oxygen carriers. So let's go forward. Now, this is daily new confirmed cases. It's not per million. It's daily new confirmed cases. And if you look at the countries in Europe, which seem to be driving the numbers right now, Italy, 55,000, France, 70,000, UK, 75,000, Germany, 200,000. So these are big numbers. Denmark, 10,000 for that small country. Hong Kong. Now there is a smattering mix of countries here, and there is a reason for that. These are the countries that are currently facing rising numbers. Now look at the uptick in the graph here. Germany going up. Let's actually look at it a little better. This is about India. If you see clearly 3 waves, the first one followed by the Delta wave, which all of us remember, where we hit nearly 400,000. Then Omicron, where we hit about 300,000. But if you look at the big 3, just for context, if you look at the big 3, UK, the green one, seems to have sort of closely followed what is happening in the US. US is the black one. And US numbers are really off the charts. You're looking at 800,000 in the Omicron wave, which for India was 300,000. You're also looking at higher hospitalizations and mortality rates than in India. Why should that be so? If you look at the European Union, if you look at European countries, all of them, look, Germany going up, France going up, Austria going up. Denmark is finally coming down. Denmark was the first to remove all COVID restrictions. and say that and they did that when they were going up, that we are now going to have to learn to live with it. Belgium kind of going up, Finland kind of going up, very low, but on that uptrend. The reason for this is their restrictions have created immunologically naive populations which haven't been exposed to the natural infection, and we will see how that is relevant. Look at the ones which had zero COVID policy. For instance, South Korea, 400,000 for that small country. 400,000 for us was an international disaster. You don't hear too much about South Korea right now. Australia, 40,000 and going up. Hong Kong, going up. Singapore, sort of kind of stable. They've managed it well, and they're carrying on with their. Now look at how the vaccines have helped them. South Korea, they've even got significant population boosted. Italy boosted. France boosted. UK boosted. Germany boosted. What have these boosters done for these countries when the numbers are still going up with the Omicron? Not much, frankly, except that the disease will probably be less severe. But we don't see in UK the hospitalizations going down. US, Russia, you see, these are the countries where even the booster doses are kind of beginning to appear. If we look at those countries which are boosted also, South Korea, right way up there, France going up, UK going up, Italy going up, Thailand kind of moving in that zone of Singapore, again, up and down, but staying stable. Israel finally staying stable. If you look at the map, you find UK. This is per million. So if you look at South Korea, it is about 8,000. They are a country which has boosted, which has followed zero COVID policy. If you look at UK, nearly 1,200. They have boosted significantly. Look at Thailand, boosted significantly, followed zero COVID policy. New Zealand followed zero COVID policy, boosted significantly. Australia going up and down, zero COVID policy. Congo, which is in the center of Africa, not boosted, not even the first dose. Probably natural immunity, can't say as of now because we don't have much data from there. US, boosted, driving the narrative of the whole world, gone up, come down, but the wastewater surveillance is showing that US may be headed for another wave. India, we have very tight waves. Our messaging has been clear that we want the entire population covered with at least one dose. We are reaching an 80% coverage. But interestingly, with even before Omicron surged, seroprevalence surveys showed us that at least in Delhi, we were hitting a seroprevalence of about 97%. And in many other states, we were hitting a seroprevalence of more than 80%. Now, when we look at that, when we look at the combination of vaccine with natural immunity, we realize that, that may be the reason why India has kind of dealt with the Omicron wave so much better. Nothing to do with what we did, only to do with the chronology of how the waves hit us. If you look at the comparison between the number of cases and the number of deaths, look at the May figures, where we were hitting about 400,000 new cases a day. And the average deaths were about 4,000. If you look at what has happened in the Omicron wave, you have hit about 300,000 a day in Omicron also, but the deaths have been a fourth of what they were in the Delta wave. One reason is that Omicron is, and I say quote unquote, milder, but I don't think that that is the main reason. I think Omicron has hit a population which already has some degree of natural or combined immunity. Look at what it has been for the UK. In the UK, it's never really come down. It's been just hovering around that 50,000 mark that they had with their second peak. And with the Omicron, they hit nearly 200,000. In the previous peaks, their average deaths were somewhere around 1,000. But with the Omicron wave, that figure has been a third of what it was for the previous waves. If you look at US, they have very detailed data. So in the US, their numbers, we were given a lot of hell for hitting 400,000 by the same press that is conveniently ignoring these high numbers for the United States. 805,000, 62 as the average. Average means it would have gone higher than that on some days and would have stayed lower than that on other days. These are mind-boggling numbers for a country that is a third our size in population, maybe less actually. I mean, US is comparable to Uttar Pradesh in population, and we'll see what Uttar Pradesh numbers are looking like. Their tests conducted, their hospitalizations, and their deaths have all been sort of stable. Despite these numbers, these have not gone up. Looking at Asia and Europe, South Korea going up, Vietnam going up, Japan gone up, coming down, Malaysia going up, Thailand going up, China sort of gone up, coming down, Indonesia, Singapore going up, India comprehensively down, Myanmar coming down, but their graph is not very, it's not very characteristic. Pakistan come down, Mongolia. Even though you see the numbers, if you see the numbers, here we are talking about 4,000, and here we are talking about 314,000. So don't just look at the size of the graph. Don't look at just the size of the graph. Look at Vietnam, 240,000. Japan, 54,000. Look at the true numbers also. And look at Germany, 196,000. Netherlands, 66,000. UK, 57,000. So these numbers are not small. These numbers, for the size of these countries, they are pretty big. In the Indian profile, if you look at the peak that we hit of 400,000, and if you see the 7-day average of 391, it's after this peak that we hit seroprevalence of about 80 to 85% of the population. The Omicron peak, even though in the rest of the world it has been similar to or larger than the Delta peak, we have had a slightly lower peak. At the peak of our Omicron wave, we were at about 300,000, and the new cases now are about 2,000, and this includes the states which are still running in 3 or 4 figures. Looking at Delhi, new cases 140 as of 18th of March with a 7-day average of 142. So it looks like we are hitting that sweet spot now. Maharashtra, 171 with a 7-day average of 225, comprehensively lower than the 7-day average. But Maharashtra is on the alert with the BA2. They are doing wastewater surveillance, and they are watching out. Uttar Pradesh, new cases 52, 7-day average 72, comprehensively less. And if you remember, last week I had said that, with the election results and the elections, and with all the crowding and not masking, we need to watch for another week or so. Well, that surge hasn't appeared. We could still probably watch the next week, but it's over here. The new cases are still comprehensively less than the 7-day average. Kerala, still in 3 figures, but 847, 850, 960, 1000. So they are also decidedly less than their 7-day average. These are the seropositivity surveys dated September, October. And if you look at Delhi, they said overall average for Delhi was 97% seropositivity. And if you look at, I think it was East Delhi, which had the highest. So South Delhi has 99%, and East Delhi had, where is East here? Central 99.5, Northeast 99.7. So that's really about 100% seroprevalence. Less than 18 years of age, which were not vaccinated, also had a seroprevalence of about 82%. 18 to 49 years old who were vaccinated had a seroprevalence of 90.3%, and more than 50 years had a seroprevalence of 92.3%. Now, interestingly, with this kind of seroprevalence, if you look at the graph of Delhi, and you remember we have been saying that it is, we are incidentally discovering COVID in people wanting treatment for other things. So in pre-op testing or hospital admissions is how we are discovering the Omicron. Look at the wealth of papers which are now saying that, and they're from all over the world. It's not just from India. It's not just a public health thing. So Science and Immunology, vaccine before or after SARS-CoV-2 infection leads to robust humoral response and antibodies that effectively neutralize variants. In this, Divya Dayanand, this is an Indian paper published on 27th December. The community seroprevalence and risk factors of SARS-CoV-2 infection in different populations in Vellore and their implications for future prevention. This paper, Antonio Laidi, this is from Switzerland, risk of reinfection after seroconversion to severe acute respiratory syndrome, a population-based propensity score matched cohort study. They say that a single dose with natural infection is protective at least for 8 months. That has been the duration of their study. Then this paper, having SARS-CoV-2 once confers a much greater immunity than a vaccine alone, but vaccination remains important. And that is what we are going to. So the public discourse, the science needs to be followed. We need to understand that immunity is a nuanced dance between several things. So if you're looking at the way the body fights the virus, it's going to have the antibodies, the B cells, and the T cells. Just a waning antibody response is not equal to waning immunity. So if the circulating antibodies drop, the memory B cells will still kick in, the long-lived plasma cells will still kick in when the body is challenged with a new infection. The T cells will have memory and will kick in once the body's immune memory is established. Looking at these immune phenomena, the European Medicine Agency, I think it's called EMA, had about a month ago recommended that we should not be boosting indiscriminately because that has the potential to cause immune fatigue. If you look at this paper in a little bit more detail, and they're very logical. This is a very logical paper, very detailed work they have done. If you see the panel A, that is showing you the immune status with vaccine alone. That's orange. The hybrid immunity is green, and the breakthrough infections are purple. Now look at panel B. If you see the IgG, IgA, IgM antibody titers, then vaccination alone has the lowest titers. If you look at hybrid immunity, it has the strongest titers. And in breakthrough infections, they're kind of approaching the density of the hybrid immunity. For the receptor binding domain, for spike protein, again, vaccine alone has the lowest. The hybrid immunity and the breakthrough infections are kind of similar, but the strength of response is more in the hybrid immunity. For the nucleocapsid, vaccine alone has practically zero response. Hybrid immunity has the strongest response, and breakthrough infections have a similar but slightly lower response. There's an outlier here, which may be an individual feature rather than the response biologically. The phagocytosis score, similarly, for vaccine alone, has been the lowest. It is the hybrid immunity which has the highest, and the breakthrough infections which are the kind of matching it, but not in strength. If you look at specific receptor binding antibodies of IgG, IgA, and IgM classes. Again, you find the same pattern repeated. Interestingly, vaccine alone, and we are discussing Pfizer here mainly, because this study is from Europe, so we are mainly discussing Pfizer. There are a few subjects of AstraZeneca, but not significant. Now, if you look at IgA, it is practically non-existent. If you look at the hybrid immunity from for IgA, titers are higher than even the breakthrough infections. IgM, that's the one where the vaccine is kind of matching all of them, and the breakthrough infections are the least. But IgM, we know, does not have longevity. It kind of dies out. So if you look at the immunity in the body according to the age, the response of the vaccine is inversely related to the age. There is an inverse correlation. The more the age, less is the response. Whereas in hybrid immunity and in breakthrough immunity, this inverse relationship is not seen. The response to an infection or to natural infection with or without vaccination is similar irrespective of age. So the conclusion was that natural infection offers a more stable immune response. They enrolled 104 participants. 31 were fully vaccinated with confirmed RT-PCR confirmed breakthrough infections. 31 had 1 or 2 vaccine doses after recovery from a natural infection. And they specifically put them in this group after investigating another feature. 42 were fully vaccinated without natural infection. Their conclusion was that there is no difference in the antibody response in those who had 1 dose of vaccine or 2 doses of vaccine in the hybrid immunity group. That's why they grouped them together. Now, whether you had 1 dose or both, but if you had natural infection, your antibody response had no titrable difference. The antibody response was robust in both hybrid immunity group and breakthrough infection group. None of the vaccine alone group had an antibody response to the nucleocapsid antigen. The spike specific antibody response was negatively correlated with age. Older people had weaker response in vaccine only group. Age did not have any demonstrable effect in breakthrough or hybrid immunity groups. Now, this is important because it means that you can actually divert the vaccines to provide at least single dose coverage all over the globe rather than boosting 3, 4, 5 or n number of times and withholding the vaccine from those who haven't had even a single dose. If we look at the neutralization titers, again, the vaccine alone group is the lowest. The hybrid immunity group is the most robust. The breakthrough group kind of matches the density, but it reaches the same titers. This is for the Wuhan strain. For the alpha strain, again, similar pattern. For the beta strain, the vaccine has dropped its efficacy to about about 2/3 of what it was with the earlier strains. With Delta, again, it is sort of the similar levels, but the Delta response is slightly better than what it was in beta. The hybrid immunity and the breakthrough infection immunity are similar in their outlook, irrespective of the variant. So relative variant neutralization has been for the vaccine the least for beta and the best for alpha, but for delta, the drop was not too much. For the hybrid immunity, it has been significantly higher for all three, but for beta, it was the least. For breakthrough infections, again, the same pattern, but the breakthrough infections here have taken over the hybrid immunity group. So if you look at the dotted line, that's the close fit of what the neutralization has been like. Hybrid immunity has been the best for all variants. Same thing, if you look at the spike for vaccine only, spike for hybrid immunity, way higher, spike for breakthrough infections, much higher, kind of similar, but it's kind of mixed bag here, but you see most of the hybrid immunity lies at the 10 raised to the power 4 mark on the hybrid. Neutralization potency, hybrid better. Gender, sex neutralization ratios. The females have responded better to the vaccines than males, whereas this difference does not exist in hybrid immunity or in breakthrough infections. Now, this is very interesting. I don't know why this is so, but it's very interesting that females have responded better to the vaccine, even though not at the same levels as hybrid and breakthrough. The vaccine alone, we discussed, has, as older you get, less is the response to the vaccine. Hybrid immunity, the response is robust and strong. Breakthrough immunity, the response is adequate, but not as robust as hybrid. So what are the conclusions of this study? Now, the vaccine is of limited supply. We know that a large part of the underdeveloped and underprivileged and marginalized populations have not received the vaccine. And we talk about how important the vaccine is. But the shortest path to global immunity seems to be hybrid immunity. The conclusion was that infection before or after vaccination gives significantly larger neutralizing response compared to vaccine alone. The potency and the breadth of antibody response are both significantly stronger with infection than with vaccine alone. Vaccine does protect against severe disease. Hence, vaccine is better before natural infection rather than after. Negative correlation between age and neutralizing response after vaccination alone. Peak antibody response in natural infection with or without vaccination is more robust and more complicated. This peak occurs at the 60 to 80 age group, but is less in less than 60 and in more than 80 age group. Boosting is similar to vaccination plus natural infection. These findings are similar for mRNA vaccines predominantly, and a few subjects that they had who were AstraZeneca recipients. So it really defies logic why we are ignoring natural immunity. Natural immunity against COVID significantly reduces the risk of reinfection. This is a study from Vellore. Again, I told you this is a study from Switzerland. So seroconversion after natural infections confers immunity for at least 8 months is the current consensus. And that is because that's the length of time that they haven't been able to study. Let's come to the second part of our talk today. All that I want to say is that with Omicron, we are sort of fortunate that that variant hasn't behaved like the Delta did. But part of that biological behavior appears to be that the countries who had bad numbers are not immunologically naive. The reason why, despite high numbers, pathology was not as severe is because we were immunologically able to deal with the virus. So coming to CBC, first part of it, this is often a lot of people, at least I did, look at hemoglobin and come to a conclusion, normal hai ya abnormal hai. But the RBC indicators give a lot of information. Current studies say that they are not just oxygen carriers, that they have an immune function, that RBCs are really the innate immune sentinels. This is the first segment of your CBC report. The RBCs are anucleate discs that carry oxygen. They do not have DNA. So they don't have any fresh genes to make or express any new proteins. Whatever they are carrying at the time that they lose their nucleus is what they will express. The exception to that rule is that some of the RNA, mRNA that does not degenerate might be expressed as a genetic agent. They last about 120 days, and we make approximately 200 billion RBCs each day. We have about 20 to 30 trillion RBCs at any given point in our body. This is about 70% of the total cell population. The turnover, somebody's mic is... The turnover, RBC elimination sites are the spleen and the liver, where resident tissue macrophages carry out erythrophagocytosis. Could everybody please mute their mics? The phagocytosis of RBCs is signaled by a decreased expression of CD47. Now, hold that thought. And it looks like the reason for anemia in infections might be related to this. So what are the immune functions of RBCs? RBCs are the primary innate immune cells. They bind the complement. They are evolved for endothermy, so we are able to manage our body temperature better because of that. They also participate in oxycytosis. So phagocytosis is where macrophages and other immune cells phagocytose the bacteria and invading pathogens. Oxycytosis is when the RBCs use oxygen to kill the bacteria. But the most important is that RBCs carry TLR9 on their surface. Now, this is a strange finding because TLR9 binds to DNA, and this is specific to a particular motif. It's the CG motif with a phosphate backbone, which is called the CPG. The main source of this motif is either bacteria or mitochondria. The TLR9 and the RNA recognizing TLR7 together trigger auto-antibody production by the triggered B cells. The antibody DNA complexes in circulation may deposit in any tissue and hence cause pathology amplification. Now, the CPG activated RBCs are associated with changes in the spleen also. So as they reach the spleen, cause neutrophilic infiltration of the spleen and also increased macrophage differentiation. There is increased splenic expression of interferon gamma and interleukin 6. So there is both a local and a systemic immune response to the TLR9 activated DNA bound RBCs. This results in the macrophages really eating up those RBCs and internalizing the antibody antigen complexes. In malaria, what you see as anemia is because these RBCs have been taken out of circulation. This is also seen in leishmania, and interestingly, it is also seen in COVID. So the RBCs seem to be the sentinel cell in the homeostatic or the balanced state. Hemoglobin is the richest source of iron for bacteria. So the bacteria have evolved to produce hemolytic toxins and high affinity scavenging systems to pick up the iron that is thus released. Evolutionarily, the host also adapts in response to this. The activated hemoglobin emits bactericidal free radicals in the vicinity of the bacteria. Both the alpha and the beta subunits of the heme molecule have high affinity binding sites for bacterial lipopolysaccharides. And this complex activates and amplifies macrophage cytokines and inhibits bacterial and fungal growth in the vicinity. Now imagine 20 to 30 trillion cells that are able to amplify locally and systemically a macrophage response to deal with pathogens. Also, these are cells which do not have a nucleus, so they cannot themselves do it. They are forming an antigen sink where they sort of pick up the cell-free DNA from the invading pathogens and deliver it to the macrophage. At the same time, they amplify the macrophage response. This is not unique to hemoglobin in humans and mammals. In the blue blood of horseshoe crabs, hemocyanin has the same effect. So what happens in severe infections and in sepsis? The RBCs get overwhelmed because there is too much circulating cell-free DNA. The cell-free hemoglobin in severe infections is also associated with increased mortality. There is a dual immunologic property that the RBCs have. The globin attenuates the immune response, whereas heme amplifies it. Globin has the ability to scavenge excess free heme during endotoxemia. Globin reduces macrophage TNF production in the presence of the lipopolysaccharide that it binds. Whereas heme triggers the pro-inflammatory cytokines under the same conditions. So it's going to be a nuanced dance between the two, depending on how much signal they're picking up. Now, heme is a potent danger signal. It activates nuclear factor kappa beta mediated increase in IL-1 and TNF alpha. It increases intracellular ROS and activates macrophages and other associated inflammatory cascade, including and not limited to the complement. Rosetting is an important stage in pathogenesis of malaria and COVID. So what happens is that blood group A and B favor rosetting and blood group O suppresses it. Is this the reason why there is more severity of pathology in blood groups A and B? Something that needs to be studied. Now, COVID-19 affects the erythrocytes in the same way. There is increased red cell distribution width. There is protein degradation. And because the erythrocyte does not have a nucleus, it cannot repair nor produce new proteins. It causes lipid peroxidation and oxidative stress. So if we were to look at the first segment of CBC, we see these parameters: MCV, MCH, MCHC, red cell distribution width, and hematocrit. Then we see the WBC indices, the ESR, and the platelet counts. So MCV, or the mean corpuscular volume, tells us about the average size of the RBCs. The RBCs can be smaller, bigger, or normal in size. The average size is between 80 to 95 femtoliters. MCH talks about the average hemoglobin per cell. This is between 27 to 33 picograms per cell. MCHC is the amount of hemoglobin relative to the size of the cell, and it ranges from 33 to 35 grams per deciliter. Now, red cell distribution width is something that we have been watching out for in COVID. It shows the variation from the largest to the smallest of the RBCs. The variation indicates different maturity of levels of population circulating in the body. So in the females, this ranges between 12 to 16, and for males from 12 to 15. We can take that figure to be around 15.5 for both. Hematocrit is the fraction of RBCs per 100 ml of blood, and ranges from 35 to 45 for females and 38 to 48 for males. So coming to the first index, the MCV, or the average size of RBCs. When the MCV is high, that is larger than normal, the red blood cells are called macrocytes. This can be seen in B12 and folate deficiency. It can also be seen in some pre-leukemias or in chemotherapy patients. When the MCV is low, the cells are called microcytes, and this is seen in iron deficiency anemia, some chronic diseases including chronic kidney disease and liver disease, thalassemia, and lead poisoning. The MCV may stay normal but the number of RBCs might decrease. So this is called normocytic anemia. This can happen in sudden bleeds, aplastic anemia, some infections, including salmonella, and some chronic kidney diseases. MCHC, the hemoglobin relative to the size of RBC. So if the MCHC is less, the red cells appear less red. And this is called hypochromia. This happens in iron deficiency, chronic diseases, lead poisoning, and thalassemias. The hemoglobin may actually be more also, and this is called hyperchromia. This happens in hereditary spherocytosis and sickle cell disease. Red cell distribution width. This has been of particular interest in predicting outcomes in COVID. So a high red cell distribution width with a typical MCV may be seen with iron deficiency, B12 or folate deficiency, and in chronic liver disease. A high RDW with a low MCV is also seen in iron deficiency or a microcytic anemia. A high RDW with a high MCV is seen, and so you can actually make out the difference between folate and established folate deficiency and established iron deficiency by putting the two parameters together. A high MCV with a high RDW may be seen in chronic liver disease also. A high RDW is seen in chronic anemias, chronic diseases of the heart, liver, kidney, and diabetes, and maybe nutritional. A low RDW or an essentially normal but not much variation in the size may also be seen in some nutritional deficiencies. A high RDW is significantly correlated with increased pathology and increased mortality from infections. It may be associated with or caused by alcohol abuse in some autoimmune diseases like psoriasis, SLE, and rheumatoid arthritis, in some pneumonias, hereditary spherocytosis, chronic liver disease, congestive heart failure, and even valvular disease. It is possible to decrease or lower the RDW by some things which are in our control. Avoid or consume alcohol in moderation. It damages the RBCs and reduces the folate and B12 absorption. So it creates nutritional deficiencies if the alcohol is abused. Stop smoking. Smoking is associated with a high RDW. This might be because of the oxidative stress. A balanced diet, as we've seen, iron deficiency, folate deficiency, and B12 deficiency are associated with a high RDW. Get good and enough sleep. 7 to 8 hours of sleep is associated with the lowest RDW measurements. Exercise regularly. Sedentary subjects have high RDW. Hematocrit. The volume of RBCs in 100 ml of blood. Now, a low hematocrit shows that there are too few RBCs, which means it could be due to bleeding disorders, it could be due to aplastic or hyperplastic anemias, it could be when erythropoietin is deficient, as in chronic kidney disease, or it could be in leukemias, lymphomas, or multiple myeloma, where a particular part of the bone marrow takes over and the other is suppressed. A high hematocrit shows that there are too many RBCs. The commonest reason for high hematocrit is dehydration. And this increases the viscosity of the blood and the coagulability of the blood. This has been seen also in microclotting studies of COVID. So the easiest way to start tackling this problem is to drink more water. Lung disease and polycythemia vera are adaptive responses to increase the number of RBCs because the efficiency of the RBCs is less. So in short, you should start looking at all the RBCs or RBC parameters because they tell you a lot. And the most important, they also tell us that the RBCs not only predict our ability to carry on with a normal life on a day-to-day basis, but also help us to sequester cell-free DNA and fight infections. They are the primary innate immune cell.
Thank you, Dr. Nidhi. Meenakshi ma'am had to leave because of some medical emergency. So I'm just here to thank everybody for joining in today's session, and Dr. Nidhi for such an insightful session. We will meet again next week, same time. Thank you.
Sapna, just a moment. If anybody has a question, you have to just ask them.
Yes, please, if anybody has a question, please go ahead.
Because and if not, then we can actually wrap up here, because this was mostly recap.
Dr. Nidhi, thank you very much,
sir,
for a wonderful, elaborate, discussion on RBCs. And one thing, MCHC, as graduates and postgraduates, we have been taught that RBC is nothing but, a container full of hemoglobin.
Yes.
Now, MCHC means
yes.
corpuscular hemoglobin concentration. You said it's 33 to 42 or something. What else is there in the RBC other than the hemoglobin?
Sir, we are that's what we are saying, that jo red cell membrane hai, that carries the TLR9 receptor, and TLR9 receptor is activated by the CG motif of the DNA, which is carried by bacteria and pathogens. So what RBCs are doing is they're not just the carrier of hemoglobin. It is a very important function that they serve, that they deliver oxygen to the entire body and take away carbon dioxide and toxins from the rest of the body. But given that it has the capacity to bind to cell-free DNA, which will be present in extracellular spaces in infections, it is also a very, very important sentinel immune cell. And since the numbers of RBCs are so high, RBCs are 70% of the entire cell population of our body. Since the numbers are so high, it is a very efficient way to encounter this unknown, little known, partly known DNA and take it to the spleen, where they trigger a neutrophilic and a macrophage response. So rather than have the whole body fight in an inappropriate macrophage or cytokine based response, you're localizing the response to the spleen or to the liver, where neutrophils and the macrophages are triggered by the TLR9 CPG motif complex and resulting in the innate immunity triggering the adaptive immunity. So this is the connection. Just like the dendritic cell is the connection. Also, if these antibody complexes on the red cell surface were to keep circulating, the macrophages that would encounter it in circulation would then form an inappropriate response. They also would trigger an autoantibody production. So the red cells are acting both as the sink and as the trigger. So the immune function of RBCs is only now beginning to come into focus. And it seems like the more the CPG activation of TLR9, lower is the expression of CD47. So the CD47 expression becoming low tells the macrophages that these are the RBCs which are now unhappy, and these are the RBCs which have to be eaten up. So the dance is very nuanced. So yes, I would say that RBCs are much more than just carriers of hemoglobin.
So we presume that practically 1/3 of RBC is doing its, the function that we were told is the primary function of RBCs, and 2/3 is something else. Volume-wise or concentration-wise.
I don't know, sir. I don't know. I think it is very difficult to put numbers to this. I think it's like you've got dal, roti, sabzi, mithai on the same plate, and you eat a little bit of everything. So the RBCs are doing everything. But the impact of all that they're doing is more because they are so huge in numbers. And because their primary function so far has been assumed to be that they are oxygen carriers and nothing more than containers for hemoglobin, we have been looking only at those parameters. Now it appears like the immune function may be the reason why we have infection-related anemias.
Madam, how to differentiate vaccine
How to
immunity and breakthrough infection immunity?
No, how to differentiate?
Vaccine immunity, hybrid immunity, and breakthrough infection immunity.
So hybrid immunity is simply अगर आपको natural infection भी हुआ है और vaccine भी लगी है. इस study में they had I'm sorry. In this study, what they did was that they took a single dose of the vaccine and a natural infection, and they labeled that hybrid immunity. Whereas 2 doses of the vaccine and a natural infection, they labeled as breakthrough infection. So this is just a matter of definition because they wanted to examine these 3 groups. Actually speaking, breakthrough infection is also a hybrid immunity.
And madam, why there is a big incidence of the antibody in the age of the 60 to 80 years?
That's because the immune system is not as robust as in the less than 80, but this is a complicated picture and needs further study. We do realize that to a natural infection, the age group between say 12-13 to about 30-35 would have the best response of both cellular and humoral immunity. This seems to be evolutionarily linked to life expectancy of humans historically. I mean, humans used to die at the age of 35 to 40. And our immune system is programmed to protect us till that age. With increasing longevity, other things are coming into play, and these are all areas of study as of now.
And madam, what is the long form of the CG? You have mentioned about
cytosine, guanine. These are the amino acids. Cytosine, guanine of the DNA.
Okay.
On the phosphorylated the backbone. So this is called the CPG motif. ये bacterial DNA में होती है. So we can.
What is the meaning of rosetting?
Rosetting, आपको याद होगा हम जो we were talking about microclots, and we said that it's stacking and not clotting per se. So rosetting is when clusters of RBCs are formed.
Same effect of that of the HIV.
Yes, similar to that of HIV, and this is because the RBCs are picking up the DNA.
Okay, madam.
Thank you so much. I think Sapna, we can.
Ma'am, with your permission, can I end the session?
Yes, Sapna. Thank you so much, Sapna, for your help.
Thank you so much for this wonderful session, ma'am. We learned a lot. So thank you everybody who's joined in, and everybody who is watching us on YouTube and Facebook. We will same time. We have these sessions every Sunday, same time at 9:30. Please join us too next week as well. Thanks a lot. Have a great Sunday, everybody.
Thank you, madam.
Thank you. Thank you.
Ma'am, could you make me the host? I need to be the host to.
Have I?
So
how, you will have to tell me how to do that, or I can end the session.
Ma'am, I'll have to actually end the live on YouTube. I don't think you can end the sessions.
Wait. So where are you, Sapna?
Ma'am, Dr. KK's HCFI. Please just click on more and make host. There'll be an option. If you click on more.
More, okay.
And there'll be an option of make
host. Yeah.